So let's pick up where we left off yesterday, which was with problem D, when we're finding the angle of depression of a goose. All right, so here we go. We got a goose that's 50 feet above the ground, and he needs to land on a small pond that is 100. Here's the pond, here's the goose, and the small pond is 198 feet from the goose, and we are finding the angle of depression. So remember, we always mark our angles of elevation or depression in the same spot to keep them inside the triangle. So, that picture makes sense to everybody? You're going to write an equation. The equation you write is always going to be sine, cosine, or tangent. Which one you want? Sine. So sine x equals 50 over 198. Okay. How do we find x? Inverse sine. That's right. Inverse sine. Or second sine. Anytime you are finding an angle, that is going to be your button.
How you doing?
Okay, or second tangent, second cosine, whatever it is. So our answer is, make sure I'm in degrees, I am. So second sine, 50 divided by 198. 14.63 degrees. Everybody okay with that? All right, so now we've got, I think we did one of these yesterday. I've got another one. We have a 105-degree angle. Oh, but the shaded region is out here. And we're finding the area of the shaded region and the length of the arc determined by the angle. So this is what we're going to find, the arc, and we know the radius is 4. All right, so what's your thought on this? You have options, lots of options. What are you thinking about? Can't hear you. What'd you say? Okay, so anytime somebody says to me, find arc length, I immediately think radius times radians, because that's how you find arc length. Now, what's the problem with this? I don't have radians, but that's okay. I know how to fix that. It's easy. So pi is to 180, as something is to 105. This is going to give me the radian measure of this angle, right? So 180x equals 105 pi. I need to reduce this, 105 over 180. Oh, let's see, 5 goes into that, 21 and 36. Now 3 goes in. I got 7 pi over 12. How does that fit? Does that seem like that's okay? Is that the answer to the question? No. That's the arc, or that's the radian measure of the angle. So I'm going to take 4 times 7 pi over 12. And I can either cancel or multiply straight across, whatever's easiest for you. But it looks like that's going to be 7 pi over 3 and centimeters. So the length of that arc is 7 pi over 3 centimeters. Okay? All right, how about the area part of the question? How am I going to find the area? We talked about this yesterday. Do you remember? What would we do yesterday? Ellie, do you remember?
You do pi r squared minus 7 pi over 3.
So pi r squared. We be careful. I see what you're doing, and that would be exactly right, except 7 pi over 3 is the arc length. It's not the area of that. okay? Otherwise, you'd be exactly right. I do like the idea of starting out with pi r squared. The whole area is 16 pi. So if you were going to eat that whole thing, if that was like your pumpkin pie, you were going to eat the whole thing. By the way, cute story, my youngest grandson loves pumpkin pie, but his parents don't want him, I mean, he's only a little over 1. They don't want him eating all that, like, crust and stuff. So I just make the pie part, the pumpkin part, for him every couple weeks, and he just loves it. Isn't that so cute? He's so adorable. He just loves his pumpkin pie. So he doesn't get the crust, he just gets the pumpkin part. All right, so the whole area is 16 pi. If I'm looking, I can do it subtraction like Ellie said, or I can actually work with this angle. What would this angle be in the colored part here, the shaded part? What would that be? 255. So the shaded part represents 255 3/60ths of the whole. Would you agree with that? So the fractional piece of the pie, if you are going to eat this, you're eating 255 of the 360. So we want that fraction of 16 pi. So we want that chunk of 16 pi. So I'm sure that reduces, let's see, 5 goes into this 51, and 5 goes into this 72. I think that reduces again. 3 goes into that 17, and 3 goes into this 24. So far I'm just reducing this fraction here. Now I'm going to go ahead and multiply, but I'm going to go ahead and cancel first actually. So it looks like the answer is 34 pi. How can that be? I did divide. Well, what did I do wrong?
3 times 1.
Oh, 3 times 1. Yeah, I forgot about that. Thank you. So 34 thirds. Yeah, thank you. How did I know that answer couldn't possibly be right? Because it was bigger than the whole. Yeah, it was bigger than the whole. So I couldn't take a chunk out and have it be bigger than the whole. So yeah, I forgot my 3 down here. Thank you. So that's one strategy. Now, could we have done 105 3/60ths? Found this area right here, which would be the area of this, and then subtracted that from 16 pi like you were talking about? Absolutely, you can do that. Just don't forget to subtract after you get that figured out. All right, so the pretest is over. Let's look at the next page, or at least in my packet stapled, it's the next page. It says practice test. Let's crank through these problems. Yes. Yes.
Aiden Broderick texted me and wants you to let him know.
Oh, well, he hasn't been here all day, or I wasn't paying attention. Thank you. Aiden, where have you been?
Well, my Wi-Fi's been geeking since the end of secret. They
Okay.
kicked me out of my class.
All right.
I'm here now, that's what matters, right?
All that matters, that's right. You're here now.
Better late than never.
Okay, here we go. I marked you unverified, so somebody will need to call the office. Okay, here we go, because you missed over half the period. All right, we're going to find the exact value. I'm on the practice test, and I'm going to find the exact value. So on this paper, if it has a star next to it, you're to use a calculator, otherwise you're not. So all of this is no calculator, which of course is what exact value means. Those of you that struggled with the quiz question, here's one just like it. All right, so let's go through this. No calculator allowed. What do you think when you look at the first one? Changing it into degrees so you know where to graph it. I mean, you could do it in radians, but it's probably easier for you in degrees. So pi is 180 divided by 4 is 45, and 5 of those is 225.
Is there fries on there?
Now, where is 225? I'm going to draw a picture of that. I'm going to make a triangle. Remember, in regular trigonometry, these are your labels. The only time those aren't your labels is when you're using the compass. So 225 would be down here like this. The angle you care about is right here. This is the only angle that matters. It's called your reference angle. And how big is it? That's 180. That's 225. How big is that angle? 45. So the sides of the triangle are 1, 1, root 2, because it's a 45, 45, 90. What do I have to remember? Negatives. If you don't draw your triangle in quadrant 1, stop yourself and make yourself put some negatives in there. Cosine is adjacent over hypotenuse. Hopefully you got negative root 2 over 2 as your final answer. Okay? Now, no calculator on this one means I got to start inside the parentheses. So this describes an angle in quadrant 1 whose tangent is 4/3. So this is a picture of the parentheses. Remember, when you see this notation, there are special rules about where you draw your pictures. But as long as that number's positive, you're going to draw quadrant 1. Remember that? Check on those rules if you've forgotten them. Now, as soon as you draw this, you know you need to do what? What's missing? The hypotenuse. So you'll do the Pythagorean Theorem, right? You want to get as much about your triangle as you can. So a squared plus b squared equals c squared. I think that's 5. And then I want the sine of that angle. It says find the sine of this picture. So the answer is 4/5. Now, here's one of these inverse functions, and it's a negative. So I'm going to draw a picture of this, but I have to remember my rule. Where do I draw an inverse sine if this number is negative? 4. Very good. Sine and tangent and cosecant are down here. The other 3 are over here. All right, so I got a sine of -1/2. That means that side's root 3, and this angle is a 30. Would you agree, across from the 1? But because, if you just said 30, 30's in quadrant 1. Because you came down, you say -30. That angle is -30 degrees. You've got another one just like that, only it's a 0. Now, remember, this problem literally says, find the angle whose cosine is 0. So that means adjacent over hypotenuse would be 0 over 1. Can I draw a triangle with a side of 0? No. When zeros pop in, doesn't that make you think about your circle? Because that's where you find zeros, right? On the axes. So if you've got a 0, you need to start thinking quadrantal because you can't ever draw a triangle with a side of 0. Which is what this would say, adjacent over hypotenuse. So, if I can't do that, I've got to think about this as x over r, right? Cosine is x. Where is x0 in that picture? 2 places. X is 0 here and here, right? But remember, with this notation, there are rules. The rules say that if this number is positive, you're in quadrant 1, but if you're negative, you're in quadrant 2. So if this function is defined in quadrant 1 and quadrant 2, then which answer am I going to pick? Because I only get to pick one. I'm going to pick the top one, sure, because it's the one in, it's not in the quadrants, but it's right there in that area. So the answer to the problem is 90 degrees. Or pi over 2 radians if you're answering in radians. It doesn't say, so we'll put down both. Okay? All right. Now I want the cosecant of 3 pi over 2. Cosecant. 3 pi over 2 is what? What angle? What degree measure? 3 pi over 2? 270. Uh-oh. Isn't that right down here? So I know my radius is 1. That's the way I drew my picture. I know x is 0 and y is negative 1. Right down there. Cosecant is the reciprocal of the sine. Sine is y over r, so this must be r over y. So the answer is negative 1. These are the ones that are sometimes undefined, remember? Not this particular problem, but some of them are. Okay, remember what the purpose of review is to jog your memory and let you know what you need to go back and spend some time studying. All right, number 2, what's the period of this thing? Oh, this was on your quiz too. What did you do to figure this out? So the period of this piece would be 2 pi over 3. 2 pi divided by this number. The period of this piece is just 2 pi over 2 or pi. So that means that if you were going to draw each piece, the first piece would start again at 2 pi over 3, 4 pi over 3, 6 pi over 3, 8 pi over 3, and so on. This is when that first chunk would repeat itself. This one's going to repeat every pi. So it looks to me like the period of the sum is, or the difference, I guess, is 2 pi. That's the first time they both start over. Is it sinusoidal? We haven't talked about that in a while. Is it sinusoidal?
No.
No, because if it were, these two would be the same. It's not. They're not. There we go. Change 2 radians to degrees. Well, that's easy. Change 2 radians to degrees. I know pi radians is 180 degrees, so 2 radians is how many degrees? What? Be careful. It's actually 360 divided by pi. Because it didn't say 2 pi radians, it just said, why did I say 2? It doesn't say 2 pi radians, it just says 2 radians. So when I cross multiply, x equals 360 over pi degrees. if it said how many degrees is 2 pi, then it would be 360. Oh, this was on your quiz too. Find a negative coterminal angle for negative pi over 7. How do we find coterminal angles? Add or subtract revolutions, right? This is a radian measure. What's a revolution in radians? 2 pi. So I'm simply going to subtract 2 pi. I want it to be negative, so I'm going to subtract 2 pi. If I added 2 pi, I'd get a positive. So this is negative 1/7 minus 14/7, so negative 15 pi over 7 is the smallest negative coterminal. There could be lots of other answers, but that would be the smallest one. In which quadrant is the sine positive and the cosine negative? Now, remember, sine is y, and cosine is x. So what you're really saying is, where is y positive and x negative? Quadrant 2. Your answer is quadrant 2. Those problems are a cinch if you remember cosine is x and sine is y. Okay, now we've got one of these where we have to find a whole bunch of different things. So we have to find all the functions. So we have to find sine, cosine, tangent, cosecant, secant, and cotangent. And we know that the secant is 5/2, which makes the cosine 2/5. So that I have going right from the beginning. Now, in the next chapter, we're going to talk about some ways we can do this problem without a picture, even though I think a picture is still the easiest way. But the problem is, I don't know where to draw the picture, or do I? Did you read the problem? What's the problem? Tell me about that. Jack? Pardon me? It tells me where to draw it. Where does it tell me? Quadrant 4? I'm going to draw this picture in quadrant 4. Does everybody understand how we know to draw the picture in quadrant 4? 270 to 360. And the cosine is 2/5. I've already done this once today. What do I need to do? Pythagorean Theorem, here we go. A squared plus b squared equals c squared. If you said root 29, you are wrong, right? A squared plus b squared equals c squared. So what is it? Negative root 21? Those negatives are going to kill you. Please make yourself stop if you're drawing a picture any place other than quadrant 1. Okay? You're going to have negatives in every single picture that's not in quadrant 1. All right, so now I can fill this in. So it looks like the sine is negative root 21 over 5, which makes the cosecant 5 over root 21 negative, which is negative 5 root 21 over 21. Tangent is negative root 21 over 2. And negative 2 root 21 over 21. How does that look? We've been doing that kind since the beginning of the chapter. We okay with that? All right, next column. Now we're going to find the arc length, the area of the smaller sector, and the area of the larger sector. And by sector, we mean piece of pie. So this is the small sector, and this is the large sector. And we know the radius is 8, and the angle is 100, And the first question says find the arc length. That's question A, find S, which is the letter we've been using for arc length. All right? So, here we go. Can we change 100 degrees into radians? So pi is to 180. As something is to 100. 5 pi over 9. Is that okay with everybody? And I'll just tell you, a mistake that's very commonly made is kids will put that in the answer blank. That isn't the answer. To get the answer, you're going to take 8 times that number. So 40 pi over 9. Do I have a unit? Nope. So 40 pi over 9 would be the answer. Is that okay with everybody? And that's the arc length. That's this distance right here. Now, there are lots of ways you can find the area. Let's do the small one first, the area of the small one. What I like to do, as you've probably noticed, is it's just a piece of the whole. So 103/60ths of the whole circle, which is 64 pi. So I'm going to reduce this. That reduces to 5/18, right? Times 64 pi. Oh boy, no calculator. Here we go. Is that 3? Well, I can reduce this a little bit. Is that 160 pi over 9? Is that okay? Okay, now, if that's the area of the small one, could I set up a similar proportion or a similar deal like that and use 260 over 360 times 64 pi? Would that give me the area of the whole? I mean, the big one? Or I could do what? What else could I do? Take 64 pi minus this, and that would give me my answer to the bigger chunk. Now, before we leave, I want to show you something that I haven't shown you because, frankly, I just feel like you have so much to memorize, but I want to give you one more piece of information. This area was 160 pi over 9. I want you to look at what happens. If I take 1/2, multiply it times the radius, which is 8, and then multiply that times the arc length, which is what? The arc length, 40 pi over 9. If I multiply 1/2 times the radius times the arc length, look what I get. That makes 4, that makes 160 pi over 9. So there is another way of finding the area of the sector if you want to use this little formula. Now, I don't memorize stuff very well, but this formula is easy for me to remember because if I kind of stretch my imagination, this is kind of a triangular shape. And I know that the area of a triangle is 1/2 base times height. This is a comparable formula, 1/2 r times s. If you think of this as the base and this loosely as the height, 1/2 rs will always give you the area of the sector. take it or leave it. We don't need it. We've survived up to this point. But if you want to use that, you absolutely can. 1/2 RS will give you the area of the sector. Okay. All right. We're done. You guys need to go to E period and get ready for the prayer service. See you later.
Thank you. Have a nice day.
You too.
Thank you, bye.
Bye. Aiden, when are you coming to school?
Probably tomorrow.
Okay, good. We have a quiz to make up. Maybe you can stay after school.
Yeah. Come to your room after school?
Yep, that'd be great.
Alright, see ya.
Thanks.